Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to Lost in Science for another week. It is, of course, 30 minutes of your favourite science communicators, radio people, whatever you want to call us. We're here, we're talking science, and with me this week, chatting all things sci, I've got Chris and Stu. Hello.
Hi, Claire.
Hi. You can call us nerds. Nerds can call each other nerds, right?
Yeah.
We can be science nerds.
It's one of the great take-backs.
Some would say Revenge of the Nerds, even.
No, we don't want to go there. That's very problematic these days.
Okay, all right. Moving swiftly along. What in the world of nerd do you have for us this week, Stu?
Well, we have talked about this before, but I thought it was about time to have a quick look at some of the things which people are doing with CRISPR.
Oh.
And the promise was huge that CRISPR was going to do all these amazing things, and it kind of has. So some of the breakthroughs we've seen in CRISPR in the last 12 months have been pretty astounding, and I think it's sort of mapping out a whole new future form of therapy, to be quite honest, in medicine.
And you're not just talking about what is in the bottom of my fridge, are you?
Absolutely not.
Which is also known for creating new life forms.
It is. Every 5 weeks.
Yeah, just reproducing old ones. Some of the oldest that exist, yes.
Right. No, CRISPR, the gene technology. Yes. Okay, great. Well, I can't wait to get an update on that. And Chris, what have you got in the back of your fridge for us today?
Mine's not so much in the back of the fridge, but in the cupboard, I suppose, or coming down at the top of the cupboard.
Pantry moss?
No, not pantry. Oh, I've got those as well, but let's not get into that. That's a whole other story. No, we're getting into approaching the summer kind of holiday season, and people are going to be traveling, and there's all this stuff about the best way to pack your luggage, like to roll it up and what to fold it, this sort of thing. So I thought I would just have a bit of a look to see if science had anything to illuminate us on the effectiveness of these different packing styles.
Chris, I cannot wait for you to tell me that physicists have spent an awfully long time rolling things up and working out what the most efficient way to pack luggage is.
I've got some disappointing news.
Brilliant. Well, let's not spoil the show. Let's get on with it.
So we've talked before on the show about CRISPR, not least because two of the people who pioneered the technology were awarded the Nobel Prize in 2020.
Oh, it was that long ago already.
Yeah. Admittedly, that might have been overshadowed by some other pressing health news when it was announced 5 years ago, like, vaccine testing all over the world for a particular virus, which we'll just not mention any further. So CRISPR, just to refresh your memory, is a genetic modification technology which is far simpler and more cost-effective than earlier methods, as well as having the advantage that it can be used to alter cells in living organisms. So previous methods of altering genes were quite primitive by comparison, and even when they are successful, they often had to be combined into extensive breeding programs to improve genetically modified individuals. So primarily, genetic modification has been used in crop plants and to a lesser extent in animals. It's been good for bringing about new populations of improved breeds or varieties primarily. Now, CRISPR can be used in similar ways to develop new and improved plants and animals, but because it can directly edit DNA in living cells, it can also be used on a much more individual level. So it can potentially change the genes of something that's already alive rather than changing the genes in a seed or something like that, for example. So as soon as the potential for that was understood, there have been lots of ideas about how it might be used in the future, and particularly the interest was in human medicine. So I thought I would have a look this week at some real-world examples of this science being put into action. And I don't remember, I remember, but I don't know if you guys remember, that when it was first announced, there was stories of people using CRISPR on themselves, and kind of injecting CRISPR-modified cells into bodies and things.
Was that scientist Dr. Jekyll? I think did something similar to that, yeah.
I don't know. I haven't seen him lately. Just this guy, Mr. Hyde, keeps showing up where he used to hang around. But no, so, I mean, that was kind of, I think it was a passing fad. I'm not sure if people who tried it also passed, but it doesn't seem to be the thing people are doing anymore. And more traditional research methods have since been applied. So one of the big news stories in health circles last year was that after extensive testing in cell lines and in animals, CRISPR therapy for HIV in human subjects was announced at the International AIDS Conference in 2024. So the research in that field is ongoing, but basically they have engineered CRISPR therapy which can clean the HIV virus out of people's blood. Now, that doesn't mean that those people are 100% cured of HIV. It hasn't rid their entire body of HIV, but it has reduced the numbers of HIV virus in the body, which can then go on to reproduce. So there's a lot more research needed into this. And there was some really interesting results that some patients had much better results than others. So they haven't really cracked exactly why it worked better for some people than other people. So there's probably going to have to be some individual tailoring to suit particular strains of virus and particular, human metabolisms. But at least it is actually a promising direction for research. Now, on the topic of tailor-made therapies, a baby earlier this year was given a personalized CRISPR therapy for an extremely rare genetic disorder of liver cells. So the disorder that this baby had was called carbamyl phosphate synthetase 1, or much simpler CPS1. And the actual disorder results in the inability to break down byproducts of protein metabolism, which leads to a buildup of ammonia in the body, which is not a good thing to have a buildup of in your body. So basically that meant that the baby couldn't eat enough protein, which meant it didn't grow very well. So they developed this CRISPR therapy. They introduced it into the liver at very low doses, immediately saw positive results.
Wow.
So they kept treating the baby. The baby was able to digest more protein. It got better. It actually got illness. It got a cold, basically, while it was being treated, and they were really worried. The baby just got better, like any normal baby would. So they just went, well, this is an amazing result from this tailored treatment. Now, obviously, you can't tailor a CRISPR treatment for every single illness that you're ever going to get. So we probably want the technology to move in a direction that will help more people and spend time helping larger numbers of the population. So one illness, one disorder, I guess, which I am familiar with is type 1 diabetes. Now, even that is relatively rare. It only affects 12 to 13 people per 100,000 population in Australia. There's not that many of the population who have type 1 diabetes, so relatively small numbers, but still enough that there are national programs to help people with diabetes. So type 1 diabetes is the body's inability to produce enough insulin, which regulates sugar uptake and results in high blood glucose levels, which in the long term cause nerve and blood vessel damage. It can lead to circulation problems, can lead to blindness, all these other side effects of diabetes. But so the result, type 1 diabetes usually results from the cells of the pancreas, where insulin is made in the pancreas, being attacked by the immune system. So the immune system recognizes these cells as being foreign to the body. They're genetically different to the host body for whatever reason, and they haven't really got a good explanation for why that happens in some people and not in others. But what it does mean is you can't just replace the tissue because the body is literally attacking the tissue. So, other things you can get, organ transplants or whatever, but you can't really do that with type 1 diabetes because the problem is that the body's getting rid of those cells that are making the insulin. So, a new CRISPR therapy that can make insulin-producing cells invisible to the immune system may be a partial solution. So they've actually injected basically cells that can't be recognized by the patient's immune system that make insulin. And they work. They've done this. They've done a trial, and they've actually had some success with that.
Hang on. So
the issue being,
so they're injecting cells that can't be detected.
They're modifying the, they're modifying the cells to be insulin producing, but also not be able to be detected by the immune system.
Oh.
So this could potentially help with other autoimmune conditions as well. But this is actually, it's a functioning model that they've got, and it's worked, and they've tested it. Not a huge number of people at this point, but it's promising research.
Within humans.
In humans, being tested on humans, yeah. So again, like I said, there's not a huge proportion of the population who are type 1 diabetics, but there's a health issue that affects about 10% of the adult population. And currently about 2.6 million people in Australia take drugs to reduce their cholesterol levels. And when you get to a certain age, it may be you. But it's a pretty commonly taken drug. It's one of the most commonly taken medications in Australia. So that would be helpful if we could figure out a way to reduce people's reliance on statins to reduce their cholesterol. Well, a new CRISPR treatment has had a phase 1 human trial in the US, was published this month in the American Heart Association Scientific Sessions, and their new CRISPR treatment lowered both LDL cholesterol and triglycerides by as much as 50%, which is far greater than any other medication has been able to manage.
Is that people who have some sort of genetic predisposition towards high cholesterol, like familial hypercholesterolemia, I think they call it? Or is it like just generally people who, as you said, have hit a certain age and their cholesterol levels have... So are we interfering with... So what I'm saying, is it a genetic condition we're solving, or are we changing people's genes to fix a metabolic kind of issue?
Well, I'm not exactly sure which process they targeted in that, but it wasn't specifying a particular disorder. They were just saying these were patients with high cholesterol. And the other thing with that is that also the effect is ongoing, so it doesn't have to be replenished according to what they've found so far. So it's kind of a one-off treatment to lower cholesterol rather than relying on a prescription. So I'm assuming they've tweaked some metabolic process to increase the reduction or the metabolizing of cholesterol and triglycerides in the body. But yeah, it has been a phase 1 trial in humans in the United States. Obviously, that's not the end of that. They need to keep looking into it and watch out if there's any side effects and all of those kind of things. But I think these examples are only some of the most recent and headline-grabbing advances in CRISPR technology. But I think this kind of advance, there may be a good chance that in future, people like Claire won't automatically think of the fridge when someone mentions CRISPR.
Congratulations on your discovery, which may well prove to be among the most significant in the history of science.
I cannot accept half-baked theories that sell newspapers. I'm a scientist.
Who are you, who are so wise in the ways of science?
A most distinguished scientist, whose name we know, even in the wilds of Transylvania.
Across Australia on the Community Radio Network, you are listening to Lost in Science.
All right. Yes, you are listening to Lost in Science. My name's Chris, and I'm bringing a bit of baggage to today's program, I guess you could say. Or future baggage, perhaps. We all struggle, I think, with luggage and try to get everything in a suitcase, particularly when you're coming home from your trip. And there's all kinds of advice out there. We've probably seen the advice, but you kind of wonder, is it really worth it? Rolling up your clothes? Is it worth being fastidious about folding? What is the best way to approach this particular issue? The hard-hitting questions I'm asking here on Lost in Science. Now, Claire, you said that, interested to hear physicists doing their usual, exploring the everyday things. I did it's not the most in-depth search, but I did a bit of a search for research on the topic, and there's not a lot of formal.
All I hear, Chris, is a opportunity, just a wide open there for all the budding physicists out there looking for a future Ig Nobel Prize. There it is.
I think there's something in there.
Oh, definitely.
I did find some researchers looking at crumpling up aluminium sheets and how that kind of affected their packing. But that's not quite what most people are taking away in their luggage. I mean, not if you want to stay on the weight limit. But anyway, I thought, we have a look at this particular issue. And when it comes to efficient ways of packing a suitcase, there's kind of two aspects to this kind of specific packing problem. Because if you look at packing problems, it is a mathematical issue. And a lot of that is about putting shapes into a space and filling it efficiently. And there's a lot of maths in how you would do that. But when we're looking at luggage, there's also the individual item of clothing. And again, it's this question of how do you prepare it for its storage in the suitcase. So kind of want to address both those aspects, and they both have the same solution as far as what I can see. Now, let's first of all address the inefficient way of putting things in the suitcase, and that is just to crumple them up and throw them in, which, as you can imagine, is not the most space efficient way of storing your suitcase, but it's one that we are prone to.
Even if you jump on them?
Well, that will help, obviously. And look, it's also, I was going to say, it's very appealing for when you're at the end of your holiday, you've got dirty clothes that you can't be bothered folding, or you don't want to fold for various reasons.
Yeah.
But the comparison here is, you think about like a piece of paper. A piece of paper obviously doesn't take up a lot of room by itself, but you crumple up into a ball, and suddenly it takes up a lot more volume, a lot more space. And you can crush down your pieces of paper, but they're never going to get quite back to as efficient packing as the original sheets. Like you 500 pieces of paper out of the box or whatever, you're not going to be able to jam them back in when they're crumpled up in the balls.
Yeah, but by that same logic, surely the most efficient way is not laying all of your clothes on top of each other in thin sheets. Is that the most efficient way?
Well, that's what you would think from that thing. But the trouble is, you're quite right. Clothing is not paper.
Yeah.
Unless you're wearing paper clothing. I don't know. Do people do that?
They did use suits. It's not a fad.
Yeah. But this is where you get into this question of, I guess, the folding versus the rolling. And certainly for a piece of paper, if you try to roll up a piece of paper into a thin kind of tube, It's not going to be generally, it's going to take more volume than if you try to like fold it neatly. And paper is a lot easier to fold neatly, I think, than a piece of fabric, which is, I guess, thicker. It's also a bit stiffer often than paper. Like doesn't fold as flat as a piece of paper.
It's got seams for one thing.
Exactly. But look, not having the time to go and do the painful maths of this, I thought I'd do a very quick experiment. I just got a T-shirt, a fairly large T-shirt that I had for convenience, an experimental, not an experimental standard T-shirt, but I got a T-shirt and I thought I will try folding it and see what the volume was. So I got this T-shirt, I folded it kind of in a fairly standard way where you kind of do the sleeves over and then, a couple of times to get a nice sort of squarish shape. And what I ended up with was a rectangle of about 25 centimeters by 31 centimeters in size. But when I measured it, it was about 3 centimeters thick, the pile of fabric. So when you multiply those together to get the volume of this kind of rectangular solid, it gets 2,325 cubic centimeters. All right? 2,325, remember that number. Now, if I took that same T-shirt in a similar way and rolled it up, instead of like folding to a square shape, I rolled it up, then I could get a cylinder that's like 31 centimeters across, but it takes a cylinder that, if I measured it from top to bottom, it was about 7 centimeters in diameter, but measuring it across about 8 centimeters because it's a bit squishy. Under gravity, it's a bit squishy, which is an important point that I'll come back to. But I went with the larger. I was trying to be generous to my folding model. So I went with the larger measurement, which is the 8 centimeter diameter, and using that as a cylinder with those dimensions, it came out to 1,558 cubic centimeters.
That's a lot less.
It was about 2/3 the volume of the folded one, which I was quite surprised there's such a difference. And what I thought maybe just by rolling up, I've squished it out, and maybe when I unroll it, it'll if try to fold it again, it will be a lot flatter. But no, it kind of uncompressed. The fabric kind of bounces back a bit. So I guess what that's saying is that if you were to try to fold it and push it down really flat, it's going to bounce back unless you keep the pressure on. So I think that 3 centimeters height that I had on it, maybe it's a bit much for your general comparison. That maybe when they've got a lot of clothes stuck to the top of it, but it's going to be still more than the rolled up one, which is a lot more, I guess, flattened, I suppose. And this should be a familiar concept to anyone who's used a sleeping bag. Let's be honest. When you're trying to get the sleeping bag back in its little bag, then if you try and fold it, it's never going to fit.
Yeah.
But if you roll it up, you're sweet.
It doesn't help that the manufacturers always make the bag smaller than the sleeping bag can possibly be.
Except you purchase it in that bag.
Yeah, but there's some magic that happens, right?
I have professionals at their factory who know what they're doing.
Professional sleeping bag rollers.
Exactly. But yeah, so I guess just on the purely up a single T-shirt, that calculation, we had about a 30% benefit, saving the space just by rolling it compared to folding it. But then there is the other aspect of it, which is actually filling the space inside the suitcase. And this is another thing where our analogy of the piece of paper fails, I suppose. I know you're probably really attached to that analogy of the piece of paper. Claire, you've kind of objected to it, I think. But you think about paper in a box, that they stack on top of each other very neatly. They fill the box quite perfectly. But that's because they're in a box that's perfectly made for these rectangular A4 sheets of paper. Yeah. Your suitcase is not quite the same. It's not the clothes are going to end up different sizes. It's not going to perfectly fill the space inside the suitcase. There's going to be a lot of gaps. There's going to be a lot of wasted space, essentially. Which is why when you're doing the rolled cylinders, you get smaller bricks that you can move around and put into more spaces. Now, I mentioned this idea of the packing problems, the mathematical packing problems. A lot of this is, people study this in maths, trying to find the best way, how many sort of spheres you could fit into a jar, for instance. And one of the challenges is that you can try and get, say, circles into a square shape. They're going to have a lot of spaces between them. So you think maybe the cylinders aren't going to be great for this because a circle is normally going to have these gaps between them. But as I mentioned earlier, these T-shirt cylinders are a bit squishy. They're not going to leave perfect gaps between them. You can actually push them into place. So you can end up with a bit more of a hexagonal packing pattern than just, hard circles. So it is actually quite an efficient way of using the space.
So people who use this method of packing are just like bees.
They're being like bees. That's how bees get the maximum honeycomb. Filling a honeycomb. Yeah.
Incredible.
Very good. Yeah. So there you go. All those, it's probably very annoying when people say, "Oh, you should roll your clothes to pack them in circles." Turns out that the maths and the physics supports that position, which is I don't know, it's kind of a disappointing news to me. But it is worth bearing in mind that it is a mathematical thing, I guess. As you say, Claire, if you jump on it, you're still not going to get as good as you're going to rolling it tightly. So when you do get to the end of the trip and you're trying to jam everything in, if it had fit just in before you packed everything neatly rolled up, there's no way it's going to fit again if you just shove it all in. So you do unfortunately have to spend that extra time rolling and folding your undesirables, shall we say, to get them back in. So something to think about when you're preparing for your next trip, I guess.
And that's all we have time for on another episode of Lost in Science. Thanks for listening. Lost in Science is recorded on the lands of the Kulin Nations and the Ngunnawal people and broadcast across Australia on the Community Radio Network with the kind support of the Community Broadcasting Foundation. If you would like to get in touch with us, we would love to hear from you. You can drop us a line at lostinsci@gmail.com. You can find us on Facebook where we are Lost in Science on 3CR, or you can just tune in wherever you find us, on your radio, on your podcast, next week when Chris, Stu, Lyndon and Claire get Lost in Science.
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.